welcome to LADYADA.
Hey everybody, we've got exciting 30-ish minutes for you today. We're going to check out what I've been working on my desk. We're broadcasting live, as we always do, Sunday nights at around LADYADA o'clock, which is somewhere between like 8 and 9:30-ish or so. But we're heading into the winter months. Got a lot of really cool, weird tech that we got in samples this week. It's going to be a little bit more of a mailbag than engineering.
Yeah, we have a bunch of stuff that we either purchased that we're sampling, or things that folks sent us, or things that we're just interested in that we've been following over the years. So we have all that and more. We also have a reminder, these are the final hours of our 20% off just for securing your account. All you got to do is make an account on Adafruit, or if you have one already, just go in, verify your email address, use two-factor authentication. You get 20% off. The coupon shows up right in your account.
How convenient.
Yeah, and tomorrow's the last day, and then after that, pretty much it's the end of the year.
Pretty much.
So these are all our sales and more. We'll see if we'll bring back that. But a lot of people secured their accounts. You can only do it once, of course, but it worked out really well. And then later on, we'll also have a great search with DigiKey. And
we have it's a jam-packed half an hour.
Yeah.
Okay.
And,
so let's get to it. Do you have any other updates or news, stuff you want to cover?
So this week we have Show and Tell at 7:30 on Wednesday, and then at 8 o'clock we have the AdaBox unboxing.
Oh my goodness!
So those are the main shows of the week, and then we'll have some of our other shows that we'll kick out. It's Christmas Eve and Christmas Day, but we'll be around. We'll be doing stuff.
Yes, we did ship every AdaBox. They're on their way. So you should have received a shipping notification if you subscribe. Congratulations. We sold out pretty much all of them, which is wonderful. And Phil and I are starting to plan the next one, which is always kind of exciting. We tend to have some soup dumplings and chat about what we think is a cool technology to bring to people 4 times a year. Speaking of, let's jump right into the mailbag. So the first thing I wanted to show off is the holidays, which means I start getting kind of cool gifts from some of our vendors. And one of our vendors sent us this sweet scroll. So I thought I'd show it off. One of the side effects of running an electronics company is you buy a lot of components from Asia, from Japan, China, Philippines, Taiwan, Korea, etc. And so you get some nifty art. This is a really, really long, I can't open it up all the way. It's a really long scroll, but it's like a silk painted scroll of the Forbidden City.
Yeah.
It's kind of cool. All right. Well, nice art. We can hang that up in our home. Thank you to the person who sent this, who I can't remember off the top of my head. Hold on. I think it's Lillian. Sorry. Elisa. Thank you for sending that to us. Okay, so scroll covered. I also got a cool, like a sandalwood comb, but I can't find it. I think I left it at the office. All right, the next up, you picked up some electronics for me to check out. You are always really into this Brainwave tech.
So this is one of those when, if not if. So over the years, I've bought a variety of like Brainwaves control an app, Brainwaves control an app, and there's some that's worked out, some that hasn't. This is one of the latest ones.
Yeah.
This is from Next Mind, and this is a dev kit.
Yeah, this is interesting. It's very elegant. So maybe I'll show it on the overhead, and then I'll show it being used. You want to do that? Because once I put it in my head, it's kind of hard to.
Yeah, we'll do a live demo with it too.
So, okay. So, thank you. So this is the board, and it's got these like cool, like rubbery contour. Hold on. What's this? Is that good? Clear. Okay. It's got these cool like rubbery contacts, and these are the electrodes, but they're like plastic coated, so they're not metal. I mean, they're metal inside, obviously. Wait. Why is this not locking? Hold on. Okay. All right. I have to remember it every week. Okay. So it's got metal inside of them, and they're like a little bit pointy-ish. I will say it's not uncomfortable to wear, but you definitely feel them on your head. And it's kind of got this like this round section and the side sections goes on the back of your head. And you don't have to have all of the all of them make really good contact with your scalp, but the more you have, the better. It charges over USB. Data is transmitted over Bluetooth Low Energy. I didn't delve deeply into the protocol, but hopefully they publish the protocol. It'd be really cool if you could connect it direct, without having to go through a computer interface. I don't know if the SDK does a lot of their analysis. And then like this part, like this is the holder and this is the actual like electronics. So that's that. So then you have to put it on your head. So I'm gonna do that next. So let's go back to the main screen. So to wear it, you do have to, the shorter your hair, the better. So that's what my hair is back up and a little bit tall. You want to put it on with the USB pointing down, which I did. And then this kind of like, I don't know if people can see it, but it has to kind of go here. And you kind of like rub it a little bit till it like kind of catches in your hair, which means removing it is a little bit uncomfortable. You just have to be careful so that you don't it's a little like having a like hair clips in, but like 8 hair clips. Okay, so all right, so now I've got it in, and like you kind of like rub it a little bit, and you can feel the little thingies make contact. And I look pretty cool. And then next step, you install the software, and it actually comes with some demos, which is nice. And it's always interesting because our muscle sensing capabilities are pretty good. Like we can do EMG sensing, but EEG sensing is really hard. And especially since this is like going through like these, it's not directly on the scalp, and it's not bare skin, and it's like you can't position it quite perfectly. But they did a kind of interesting hack. So let's go to the computer, and we'll launch this application. Hold on. Okay, yeah, it's a demo. Okay, great. So this is the demo app. And the first thing you want to do is calibrate. I haven't, I didn't really read the full manual, but you probably have to calibrate like almost every time. So you turn it on, and you press the button to turn on, and then in the top right of your screen, yeah, so you see now it says it's connected. And you see this little icon in the top right. This shows you how many of the contacts are touching your scalp properly. So right now they're red. So let's connect, and we'll fix that up. So you basically kind of like rub it until you get all the dots turn green. Okay, great. So I'm good. And then here's how it works. So it's not like, sci-fi where it's like you can read your thoughts. Instead, what they do is they like trigger your visual cortex or whatever. They trigger your vision system with this like flashing pattern. And then if anyone like remembers Duck Hunt on the NES, and it was like, how does it know where the gun is pointing, right? Like you point the gun and you shoot the ducks. How does it know? And the answer is it doesn't actually know where it is. What it does is it flashes every item white, and then with the photo sensor on the shooter, the blaster picks up that light. It knows sequenced which one you were just pointing at when you press the trigger. Like there's really good videos about how the duck gun blaster works. So go watch those, because once you watch that, you'll understand how this works, which is it sequences and then checks for your visual like activity that is matched with the timeline of when it flashed that block. So, all right. So now I have to like stay focused. So you see the flashing dots, and then you want to look right at it, and it's like you don't have to focus or concentrate, but what you want to make sure is that you don't have other like muscular movement, and you're staring right at these like flashing like specks. All right, so I'm halfway done. Just keep staring. You get really good at staring. little brain in the background. Okay, great.
One thing I'll mention, this is also kind of meant to work with like an Oculus at some point, like either
yeah. So then
the new model or existing models, because you can imagine this is just another thing you can do inside of a game. But I'm more interested in like you use one of these and then you use it to control like a physical device.
You can, but I'm always like really a little cynical about EEG stuff because I know how hard it is to do. So I'll show you basically the reaction time, and it's like 2 to 3 seconds per focus. So in this demo, you have these circles, and I look at the one on the very left, and then that one, and then I look at the one in the center, and that triggers. Then I look on the one on the right, and that triggers. So you see, like me looking at the thing, and it's not like a focus thing. You're just looking at this thing, and then your visual system like gets triggered. That is like it's a 2 to 3 second delay, right? So it's not instantaneous, which is okay. It's just like you have to know what you're looking at. So then there was like this demo where you play a video game and you see how they do the control. What you do is at the bottom there's like 6 spots that you can stare at, and then when you stare at one of those 6 or 7 spots, that's where the paddle goes. So you're not thinking about where it's going, you're just staring at that spot that's triggering your brain, and then you see each one goes in they go in like order. Each one flashes one after the other.
Just to be clear, everyone, Lamora is looking at the pattern on the screen. It can sense that she's looking at the pattern on the screen through her brain waves.
Yeah.
And then it moves it there.
I'm not...
So I think this is pretty impressive. Like I've said, I've tried a lot of these over the years because I know this is going to happen one day. And it's just like, hey, I wonder what the latest is. And so I thought Next Mind, so far, I think they did a good job.
Yeah, I mean, look, I think it's pretty neat. I think it's a cool hack that they did, right? It's not saying this is what it is what we can do, and the fact that you don't need to have
this is 2020 with
like implants. You just put it on your head, you calibrate it, and
you're pretty advanced thing for what it can do. And now the other piece of this is with the game development system Unity, which you will use to make your own games. You can do a lot more with it.
Yeah, so it's one thing that they have that's neat. Now I'll say, like, I do not know squat about Unity. Unity was one of the SD. This is like one of the development environments that I just never learned. I had to do like Java servlets and like Tickle TK, but somehow I missed Unity. Right, this is like one of the things I never learned, which is a shame. It's very powerful, but they have the ability to basically create these blocks and then trigger things. Like it's not a 3D. Like, there's no 3D modeling involved in using this. You just have these visual blocks. But I think they're like, well, if you're going to use a graphical SDK, Unity is a really easy one. And then you can, of course, tie it in with video game systems if you want to do, like, game control. So in this, like, I created, like, I figured out, with a little effort, making this background. And then you can create one of those flashing blocks that you have to stare at. The only thing is that, like, I couldn't... something happened with the scaling. I couldn't figure it out. So, like, it's like I can't quite get this to work. Like, it kind of tries, but it doesn't detect to me because it's not flashing white and black. It's flashing, like, gray and black. I don't know. I have to... something with the lighting. But somebody with Unity experience will probably be able to figure this out much easier. It comes with some demo examples. There's even a simulator and stuff. So, this is kind of cool. So, that's the Next Mind demo.
Yeah, someone else, is it possible to develop your own apps? Yeah, that's the whole point of it. Like, it came with that demo.
Yeah.
But the whole point is you use Unity and you make your own apps.
Yeah, so you make the blocks, and then the blocks, when somebody looks at it, it triggers your app and tells you, this is the block that they looked at. Yeah. So then what you do is that you have each block, like, perform an action. And then, I know for a fact that Unity can communicate with, like, Arduino or Python because there's hooks and stuff for... USB to serial. So if you want to have this control hardware, I basically gave myself a time bucket of about an hour, and like I didn't get much further than that. But I know it's possible to make it so that you stare at these different tags, and then it triggers your brain triggers it, and then it sends a command. So over USB serial, and then like a servo moves or LEDs light up, or it controls like a wheelchair or something. So kind of interesting.
The thing that we'll probably see soon is like an accessory for an Oculus that allows you to have yet another way you can control something in a game. It's probably a Star Wars tie-in where you look at a thing and it's like, okay, you're using the Force and it's moving stuff around. That's probably the first obvious one because they probably want to get a lot of sales so they can then decrease the cost of these things, and maybe eventually they'll be built into all the devices. But anyways, that's the current like state of the art for some commercial game Brainwave readers.
I mean, it does work, right? Which puts it, pretty, like, for me, anything with EEG or EMG, if it works, I'm like pretty impressed.
Yeah.
It's really hard to do.
The other thing, and maybe we'll show it in a future show, that's not game related, this is more medical related, is the Cardia. They actually work. So if you want to do a home EKG, it's really neat. And anyways, we'll show one on a next Desk LADYADA in the future. But that's another neat one that has this is really advanced technologies now getting in the hands of regular folks. Okay, so speaking of hands.
This is a handy board. So speaking of, we also got samples of the HiFive Inventing Coding Kit from BBC and Tynker. And as a side, I have no connection to BBC or Microbit. I mean, we purchase Microbits and we sell them, and I watch Doctor Who, and it's fun. I think it's interesting that the BBC went with two different Microbit shaped boards. There's the Microbit 1 and V2, and then they also did this side project or I don't know, with Tynker to do this RISC-V based board, which is kind of cool and powerful, and it has a lot of, it's definitely not like a Microbit replacement. It's the next step or an analogous. It has way more capabilities. It's also more expensive, and it uses Tynker, not MakeCode, although there's a lot of similarities because it has block-based programming and also Micropython. So it's kind of interesting. It definitely has a lot more capabilities. I mean, you're paying for it, but if you want to have a much more powerful board that has more functionality, but it's a step up from the Microbit, I think this could be you get a Microbit, you try it out, you play with it, but then you're I want Wi-Fi. This would be a good next step.
Yeah.
So let's look at it on the overhead. So.
Yeah, one thing that someone pointed out, it has a Microbit connector, but it also has a hamburger helper-esque shape.
It is hamburger.
So it has a hand.
Once you say that, you can never forget it. It's definitely a hamburger helper.
And Lydia will talk about this in a little bit, but just my thing about this is it's one of the first examples. It might end up being the first most used sci-fi RISC-V chip.
Yeah, it's definitely the first retail ready sci-fi chip, RISC-V chip. It's the HiFive Sci-Fi based on RISC-V. So
and why do we like RISC?
RISC architecture is going to change everything.
Yeah, RISC is good.
Okay, so
that was me and Phil when we were in our 20s.
In the day. So
okay,
that's why I had shorter hair.
Yeah. So so let's check out what it comes with first, and then I'll actually go into the board. So let's go to the overhead, if that's okay.
Yeah.
Okay. So it comes with the board, which we'll talk about, and it actually came in a case, which I extracted it from this case. So it's actually a really beautiful case. It's got the hamburger helper hands, light sensor window, and it's got this clear window for the LEDs. These heat tacked button thingies, reset button thingy, and then a protector. And it also comes with a battery pack, and I gotta give them props. They have a battery pack with an on-off switch, which I love. I really, really like on-off switches, so people don't have to yank out the battery. But it's the same polarity as the Microbit and all of our boards. So you can probably also plug in a LiPo. It won't recharge, but you can use NAA batteries, 3 of them, which is required for the high power Wi-Fi. And there's also a little speaker dongle. This looks a lot like the Simon Monk add-on, but maybe he worked on it with them. And then it's got a 1 watt 8 ohm speaker, a little amplifier, and then you can, for doing audio projects and stuff. Okay. And also it's got these alligator clips, and I got to give credit. Check this out. Have you ever seen a clear alligator clip? I haven't. Those are cool. Very cool. All right. Okay, so then let's get to the meat of the matter. The hamburger helper of the matter. This is the Inventor Board. Okay, so the first thing you notice is, yes, it has the microbit friendly edge connector, which is cool. You can alligator clip to it or plug it into microbit accessories. Obviously, it's not the same chip as a microbit, so it's, you're going to have to use accessories and figure out what the code wiring pinout alternative is. It's got the A and B buttons. It's got, instead of 5x5 red LEDs, this is actually neopixels. So it's got 6x8 neopixels, which is pretty cool because you can do like full color images and animations. And they look really nice. It's in a nice grid. This is the RISC-V chip. This is a light sensor, although, this looks a little bit like a light/UV sensor. I don't know what part that is, but it looks a little bit like a UV sensor to me. And then light and UV. And this is the 2 buttons. And then on the back, it's like a smorgasbord. So this is the capacitor grid for the back of the neopixels. That's nice. This is the accelerometer compass, magnetometer, got the RISC-V logo. It uses an ESP32 as a coprocessor. I'm like 99% sure that this is wired up as a UART device to the RISC-V chip. There is a flash SPI memory chip. It's a IS25L004, so I think maybe it's half a megabyte, although, I can look up the schematics probably. It's got a fuse here, probably for the neopixels, because you could definitely, if you turn them all on white, they'll use a lot of power. Freescale, whatever, MX22F, this is, like on the microbit, this is a chip that acts basically as a J-Link compatible debugger, programmer, and USB to UART converter, because this RISC-V chip does not have native USB, which is why we don't have CircuitPython for it. I would really hope if they do eventually come out with a native USB chip, I think we could be able to port CircuitPython for it. But for now, it's Micropython only because it can't show up as a disk drive. I got the reset button, little power supply here. Looks like it's a little buck converter, I think, or maybe it's got 2 inductors, so it could be a buck boost. So if your batteries run low, it'll boost it to 3.3 volts. Over 3.3, it'll buck it down to 3. You do need quite a bit of current for the Wi-Fi, so they had to probably do a little bit of better job on the power supply. And then the battery connector, and then a micro B. So, it's fully packed. So, cool things about it. Hardware are, fully featured. Like, you get so much hardware. And this would actually be a great dev kit for just doing RISC-V development. You want to explore RISC-V. Yes, this comes with, student programming setup for Micropython or block-based programming, but I think it would also be great if you just wanted to program it in straight C, which I'm sure HiFive provides an SDK for. If you do want to use it with the programming system it comes with, it is a little bit of a walled garden. So that's something that it's like a pro-con. When you buy this, you get a serial number. You have to register it with the serial number, and then you can't give it away because the serial number has been used, right? So there's only like 1 user per board, as far as I can tell. So it can't be shared with people unless they also share their password and login. I mean, I could be wrong, but I tried making another account with the same code and it wouldn't let me. So that's that. So let's quickly check out the Tynker coding system.
Yeah, and just a reminder, we have this. We'll have these in the store. So you can just go to the links I put in, but you can just go to Adafruit and sign up. Just search for.
Yeah. So this is the block-based programming, and it comes with, it's got Lady Doctor, and she's has adventures, and she's like rescuing aliens, and there's block-based programming, and it is kind of cool that there's Wi-Fi built in. So I did get this very basic example working. Where you connect to Wi-Fi, and then on connection you get a smiley face, and then you're fetching data from Open Weather Map. So they give you a URL with the JSON data comes out, and then you can parse the JSON data from within the block-based programming, and you just kind of, a little bit like the way the PyPortal works, you give it like the JSON path, and then you can extract that data and display it. So if we go to the overhead real fast.
Yeah, this is a good example of if you wanted to do like IoT with a
It's
block-based thing.
it's cool.
This is one of the first times I've seen this work.
It does work, which is pretty amazing. So if I reset it, the green dot means it's like booting, and then you see the face means okay, connected to Wi-Fi, and then it says it's cloudy in New York. And by the way, it's cloudy from now until like March, so that's not that exciting.
But that's real data.
But you can get the JSON data, and there's also a MicroPython for it. What's kind of neat is that you can download this data, and it uses. Okay, go back to the computer. Although I don't think you'll see. I don't think it comes through. Oh no, it does. So there's. It can do web Bluetooth for pairing, although I couldn't quite get it to work. But it can do web USB pairing as well, which is, like, in my opinion, preferable because I'm connecting it over USB. And then it has a really slick, like, uploading system. So this is a paid coding platform, but it is quite nice. There's a lot of, like, little flourishes that make it a nifty way to program. Like, in the MicroPython land, like, there's a Python tutorial, there's a MicroPython learning system, and it has one thing that I thought was really nifty while doing this is that you have these code chunks within the browser, and then you can deploy it directly to your board, like directly from within the browser, which is neat. Like, it's very tied together, which I thought was very elegant, right? There's no like, oh, you have to go to the editor and change it. I did really like this slick, like within that, div CSS block, you click deploy. It compiles the code into the MicroPython hex file. It sends it over USB serial or web Bluetooth to your device, and then it reboots it. So then if you go to the overhead, it's got the let me see, reset it. It then displays hello world. So that's pretty cool. So very interesting. But yeah, it is a walled garden, right? Like, this is, if once you're in this system, like, I actually couldn't figure out how to, like, there's an editor for writing MicroPython, but, like, I actually couldn't figure out how to get to the MicroPython REPL. Like, admittedly, I didn't spend more than, like, 3 minutes, but it was, like, I tried all the COM ports, I tried different baud rates, and, like, I got, like, a boot screen for the sci-fi, but I couldn't get into MicroPython, so I don't know exactly how that works. But hopefully more documentation will be forthcoming, or I'll find it, or somebody will tell me about it. So that's the Inventor Kit.
All right, so that's our mailbag. Those were the things that we're going to show this week. But you were noticing some things, and then that was going to lead you to the Great Search.
That's right. So I was thinking about, we'd already covered, I think.
But wait.
Oh, wait.
Is it time for Great Search?
Yeah, it is.
It is? Okay.
Do the audio.
Where in the world is that part I need? The Great Search with DigiKey.
All right.
Okay, now we're ready. So we had done great searches about, like, buttons and USB and SPI flash, but I realized, like, we hadn't actually done a great search about crystals and oscillators, and I thought that would be a good thing to chat about because, almost every microcontroller and also audio chipsets and some USB chipsets require a crystal oscillator, and I thought it'd be good to show how to find the right crystal for your product, because not having the right crystal, it's really easy to get the wrong ones, like, misspec them, and then nothing's booting, nothing's working, and it's just, like, confusing and weird and frustrating. So, getting the right matching crystal for your chip is a good idea. So I pulled up the SiFive FE310 datasheet. And, like many chips, you are required to have a USB crystal. Now, I will say that there are some chips and these are some of my favorites, that they have an internal oscillator that's like, somewhat precise. And when you connect them over USB, they actually can synchronize with the precision 1 kilohertz pulse that comes over USB. There's this 1 kilohertz, like on the dot pulse that the host computer sends. And the chips can synchronize with that, and they tighten up their built-in resonator. They PLL against it to be able to get good enough 12 megahertz or 24 megahertz or 48 megahertz internal oscillation to be able to do USB, which requires pretty good timing. And like the SAMD21 is an example of that. So really like that. SAMD21 can do it. I think the SAMD51 can also do it. Famously, the FT232RL was one, and now the Scilab's CP210X series. Historically, USB to serial converters required a crystal. Now they don't, because they synchronize over USB. But in this case, this chip does not connect over USB, and so you do need to have a crystal driver, crystal oscillator. So you'll need a crystal. You'll want to look at the megahertz, of course, it's very important, 16 megahertz. And you want to find the capacitive load. In this case, it's 12 picofarad and the ESR. I will say you have to be on the dot for the crystal frequency. You can't do 11, you can't do 12, you can't do 20, you have to do 16. For the loading capacitance in the ESR, you can have a little bit of variation. It does not have to be like on the dot, although if you can, the better it is. So going to DigiKey now. All right, so let's look for a crystal. This is like, I feel like I'm playing Final Fantasy. Kind of go find the crystals. So there are there's like crystal kits, which are super cool. There's crystals, there's oscillators, and there's resonators. And it's a little bit confusing which is which. So let's go to resonators first, because those are like the easiest to explain. So resonators are like these things, and they're ceramic resonators. And what's neat about them is they have 3 pins, because they actually have like the capacitive loading built in. And whenever you have a crystal, you can pretty much use a resonator. It's not going to be nearly as precise. It's going to be, I think, plus or minus 0.2%, plus or minus 15%. But what's really nice is they often have this built-in capacitor, which means they're smaller, they're easier. I love these for boards that don't have high precision timekeeping, but you still need to have some sort of crystal. So let's actually show an example, because I have one on my desk. So if you have, I'm going to get real close because these things are small. Let's get small. Okay. So here you've got the, you can't see it, but it says Atmega 328. And the Atmega 328, while it does have an internal resonator, RC oscillator, you want to have really good timekeeping, you want to have a crystal resonator. And to keep this board inexpensive and small, you'll see it's got this 3-pin resonator here. It's, I think, a 16 megahertz resonator. Less expensive. Is it good enough? Yeah, it is, because the only really strong timekeeping thing that you have to do on this chip is UART, and the UART plus or minus 0.2% is way better than what the internal chip can match to anyways. Like, you're not going to be able to, for a lot of frequencies, the divider for the UART peripheral isn't going to be that good anyways. It's within 1% is fine. So ceramic resonator is A-okay. Much cheaper, only one component, super easy to pick and place. I do love them in many situations. They are not high precision devices, but in many cases they're good enough. Okay, so think about how accurate do you need your timekeeping? That's what you have to keep in mind. All right, so that's our resonator. Okay, next up is oscillators. So oscillators, so let's pick out, actually I should have probably done a little more research because I want to make sure that I have the right naming. Let's pick out a 16 megahertz here. Yeah, they have like every frequency known to man. Okay. Open the data whoa, nope. How do you open that? Okay, so this is a oscillator. And an oscillator, now I think of it, I think this is actually a crystal. Let me see, maximum rise time. It doesn't have the pinouts. Okay, so in general, while I don't see the pinouts here.
Want me to go to the computer, or what do you want to do?
Oh, sorry, yeah. I thought we were at the computer. Yeah. So in general, oscillators, when I say oscillator, and this, I don't have a pinout, but I'm going to assume this is the right thing. An oscillator is basically it's a crystal with a little driver inside of it, and it also usually has the capacitors inside of it. It looks just like a crystal, but you give it ground, you give it power, and it gives you a signal output. So you don't need to have 2 pins. It's for chips that require a clock in but don't have a built-in crystal driver. In this case, how would you know? Because for the Sci-5 chip, it tells you that there's a crystal in and a crystal out. If you have a crystal in and a crystal out, you're not going to use an oscillator, you're going to use a crystal. Or if you're a cheapskate, you can use a resonator. But there are sometimes chips that do not have an input and output, they only have an input. And in that case, you need to use an oscillator. For example, the WM8960, or it's 6980, the audio driver chip that we use on the audio bonnet, it's an I2S, input, output, speaker, headphone jack, microphones. It's intending to have a 24 megahertz M clock signal. It doesn't have a crystal driver, and so we use a crystal oscillator on that to give it a nice clean 24 megahertz as a square wave into the chip. So now you know the difference. But let's go back, and we're going to go for a crystal. So oscillators tend to be a little bit more expensive. So that's the thing. Oscillators are kind of the highest end. They're beautiful and wonderful. They have all-in-one. You have to do almost no work. You don't have to worry about loading capacitance or anything. Usually, you give it 3 volts, you get signal out. Beautiful. But they're a little more expensive because they have more stuff. So let's go to crystals. The crystals, you have 2 pins. Sometimes the package has 4 pins, but the device itself has 2 pins. The first thing you want to do, other than, of course, set your active, is you want to pick your frequency. Pretty much every value you could possibly want is available here. But you definitely, and it's like some of them are like really weird values, like 16.000312 megahertz. But there's some use for it, right? There's some device or multiplier that it works out that's a valuable frequency. In our case, we just want a solid 16 megahertz to match what the datasheet says. Next up, I'm just going to look for items in stock. And then you have a couple of choices. The first thing is you want to maybe look at the packager case, because there's pretty much 2 packages-ish for crystals. You can either have this gigantic, chunky HC49 package, and they come from this nice svelte, thin, top hat version, to they get really tall, and sometimes they get really tall. Let me show you some of the really tall ones. Something they're a little scary how tall they are. They get super tall. They have surface mount versions, they have through-hole versions. Oh yeah, tall, very tall. And these are classic crystals. If you open up your old electronics, you're gonna find these in there. These are the classic tin can speakers. And if we go to the overhead again real fast, we can look at this Arduino has one, right? It's got that lozenge HC49. Benefits of the HC49, ultra generic, extremely low cost, but really big. So I think we're going to pass on those. So we're going to select not those. Oh, there's also the cylindrical can. These are they're also kind of like a cousin of those chunky ones. Sometimes you see those also. They're a little smaller, but they're through hole only. Again, very inexpensive. The rest of them are basically you can get SMD, and they all kind of look like this, which is really nice. It's a standard pinout. They're nice and flat. They come in different sizes. There's like, from 2 millimeters by 1.6 up to like 12 by 4.6. In general, I stick to the 3.2 by 2.5 to 2.5 to 2.0. These are like the standard crystals. That's what you have on this HiFive board. And then, of course, we're going to look at the load capacitance and the ESR. If you get the load capacitance or ESR significantly off, your crystal's not going to oscillate. You're going to be bummed. So let's check out what they recommend. 12 picofarad, 80 ohms. So let's go 12 picofarad, 80 ohms. And, you can kind of wiggle around. Like, it doesn't have to be exact. I mean, I shouldn't say that, but, it's the truth. And then you got a lot of choices. There's you're going to pay for a wider operating temperature. You're going to pay for frequency stability. 10 ppm is going to be, of course, more expensive than 100 ppm. Also, the frequency tolerance. So, how close is it to the frequency, and how much does it stay within that temperature? To that frequency over the temperature range. The better, the more expensive. So it's up to you to decide. But you can just look at, the least expensive one, which I think I ended up with this one, the FA238. So this one is plus or minus 50 ppm, 10 picofarad, 80 ohms. And it's got it's this classic 4 pad SMD package. 2 pins are actually connected to the crystal. They're kitty cornered. And the other 2 are just mechanical stability. Just watch it. It's symmetric. You can flip it either way, which is really nice. But just make sure you get the right 2 kitty corner, because once I didn't, and it was very frustrating to solder it on in the right place. So just make sure that your package is correct. Other than that, you can get a crystal for 12, 20 cents, and then you just figure out what is your temperature scale that you're operating at, and what is the frequency requirement you have. You will probably back calculate from the thing that's the most precise you have to deal with. Are you generating HDMI? Are you connecting over high-speed USB? Are you doing TTL, LVDS display driving? All these things are going to affect what your timing requirements are. If you need long-term timing, you probably have a separate RTC. But for every day, just keeping your device running at the frequency you think, crystals, it's where it's at, and that's the great search.
All right.
Where in the world is that part I need? The great search with DigiKey.
Okay,
that's our desk LADYADA
wait,
for
I
tonight.
have one last thing to show, but
I
it's
did have a
extreme
couple things that came in, so
Yeah.
let's do your thing, and we'll.
Okay, let's do my thing, and then we'll show the other thing, and then we'll answer any questions. So I also got these really cool e-ink displays that are super contrasty. So it's very bright in here, so it's hard to tell. But these are compared to these sort of off-white. These are really
they're really
light.
high contrast, really sharp.
Very sharp
e-ink.
EPDs. It's a new technology that's ultra the whites are really white and the blacks are really black. That's how I can explain it. It looks like paper, much more like paper, compared to sort of the off-white of normal EPDs. Although normal EPDs look pretty good too. Anyways,
Okay. Dawn asked this question, and I had suggested check out particles. That was I'll pre-answer it for you, but you tell me what else you think.
Yeah.
So the wireless carriers claim that 5G is going to be great for Internet of Things. Do you see any 5G modules on the horizon that you would include in a 5G feather phone? I said the particles.
Check the particles
that are out there, because
yeah.
they have a business model that makes that work. For us, we have to find a module that's good and low cost. But what do you think, LADYADA?
I think that actually you're not going to use 5G. You're going to use NB-IoT, because 5G is insanely expensive, and so is 4G. And I think in LTE, it's so pricey, and NB-IoT gives you not the super high-speed connectivity, but for most IoT projects, you don't need that. And I think NB-IoT is kind of where it's at. It's low cost, it's really easy, it's inexpensive, and it's taking advantage of the current 5G networks without having to spend the money on a full full-featured 5G module. Now, of course, if you're making a device that's transmitting like video or audio or like other ultra high bandwidth needs, yeah, you'll need a full 5G module. But you're sending temperature and humidity and maybe taking a photo and sending it back and forth. It's okay if it takes a minute. NB-IoT is what you want to use.
Yeah, and then someone's asking about Gen 2 MagTechs coming. Yeah, we're going to have a menagerie, a myriad of MagTechs, because if you think about every type of display
I have so
possible,
many displays. I just haven't had a chance.
It will be a cornucopia.
But I wanted to try out these
MagTechs.
These are really beautiful. These a very fast refresh and very, very beautiful e-ink displays. But it's a little bit of a challenge. Like e-ink displays are just they're constantly being updated. It's a little bit of
There's
a chase.
Reason you don't see anybody out there doing e-ink the way we're doing it, and that's why we had called it Think Ink. And the way that we approach it is it just works. You can use fonts and images and graphics.
Yeah.
And you can do more than one project, and you haven't spent 8 months on it. So definitely compare not only the hardware.
There are so many chipsets.
But compare. Just look at take a Arduino ink project and then take a CircuitPython ink project, and just see the differences on how easy it is to do one versus the other.
Yeah.
Because eventually, when hardware becomes similar, it's about the software and a lot of the behind the scenes stuff that makes it work. So anyways, check that out. That's what we're spending a lot of time on.
Yep.
As well.
Okay,
that's our show for the night.
All right, thanks everybody.
See everyone.
Have a great night. Have a great week. Don't forget, we've got...
Oh, there's one more question.
What?
We'll sneak this one in. Question, working on a low power project using a sharp MEM display that needs refresh with software hardware. I'm using hardware refresh and using a 555 to provide the 30 hertz signal to the display. Is an oscillator a better choice?
Oh, an oscillator will do the job quite nicely, but it's going to be really fast. So you have to... I would see if maybe your device, if your chip, maybe it has some sort of low power timer output. That would be ideal. You don't have to refresh it more than once every few seconds, to be honest. You can go about a second or two in between. So that's 1 hertz, and there's not going to be an oscillator necessarily that does that. And by the time you divide it down, it's no longer low power. So first off, I'd see can you send it a higher frequency signal? Because I think there are some oscillators that could do maybe a kilohertz, maybe less. But take a look. If there are, it'll definitely do the job, because you just power it and it gives you a square wave out. Very simple.
Okay. Good question. Good way to end it. We'll see everybody after the holiday this week.
Yes.
Please continue to have a happy, healthy holiday. We all just got to wear masks, keep some distance, not exchange air with others just for a little bit. Just
how hard can that be?
Yeah. Well, we made it this far together, so let's keep going.
Okay. All right. Thanks, everybody.
We'll see everybody next week.